Jesus Christ. I wonder if they filmed that. I'm just gonna implement this for now.
You okay?
Yo,
Hey, what's up, bro?
what's up? How's it going?
What's up, bro? Doing good, bro. How about you?
Good. Just building something real quick. What are you working on?
Honestly, I was just looking at the swarm because, sometimes I hear Steve talking about it. So I was like, you know what? It's been a long time since I've looked into the GitHub first. I was just looking into it and just seeing some issues. Because over the winter, I just want to start because I'm traveling back home, so I was like, since I can't do hackathon, I might as well contribute towards open source.
Oh yeah. Oh, now I know who's talking. I didn't know who was talking because your Discord username is like completely different.
All right. Because this is my OG Discord. That's why.
Oh, nice. Yeah. If you want to pick up, any issues that like are listed, that would be greatly appreciated. So
Yeah.
yeah. Um,
I'll just send a PR once I have it done.
yeah. Sounds good.
All right. So how's everything going with Swarms?
Everything's going good. We have a new update coming out. We just had a pretty big like special week for what is it, Black Friday,
Uh huh.
and we had like massive discounts for our subscriptions. And on Black Friday we had 100% off 24-hour only special.
What do
um
you mean 100% off? So it's like free?
yeah, for the API called Frenzy Mode.
Uh,
You should check out our
okay.
Twitter. Just check the Twitter. It's super cool.
Oh
um
no, because I only follow your LinkedIn. Because like I don't use Twitter. I have to start actually. That's a good point you mentioned.
you don't use Twitter?
I'm gonna be honest. No,
Damn, bro, that's
I have to like low key start. A lot of people will be posting on X nowadays. That's
that's
why.
that's crazy, man. That's crazy. Yeah, bro, you should go on Twitter. Follow me, and follow Twitter, bro.
So it's just Kai Gomez and Swarms. Yeah.
Yeah, yeah, yeah. Kai Gomez
All
B
right.
and Swarms underscore Corp. The Swarms Twitter should have like 47,000 followers. So yeah.
Oh, you have a big following on X.
Yeah. Yep. Yeah. Yeah, we do.
I guess I'll make sure to check it out.
Yeah. Also, by the way, I'm streaming right now. So
Wait,
uh
dead ass
yeah, I don't know if you knew, but yeah, I'm streaming
streaming where?
on YouTube and also X.
So like, what exactly are you streaming?
I'm so right now I'm streaming, like I'm working on a new model architecture using Mamba. So
Uh huh.
Mamba is a competitor to Transformers, and basically I'm working on a new architecture that basically replicates the Transformer block, but with Mamba instead. So,
Mm-hmm.
but yeah, you could check out the screen to uh, to see what
Where
I'm
is it?
doing. We have a question. So, what are you working on? Yeah, I'm literally trying to like build a Mamba block that like basically follows how Transformers work, because Mambas just have like, it's just like a Mamba. It just has like a Mamba block, and then you do that like 20 times or 15 times, and that's all a Mamba model is. But I have a thesis that if we add, like, for example, MOE to a Mamba, I think it could do really good. So I'm basically just literally copying. Uh, I'm like taking a transformer and just putting a Mamba in the transformer instead of just having attention, no attention. Um, yeah, lots of new hybrid architectures with Mamba. I think hybrid architectures like could theoretically be. I think it could be useful, but I don't know. Like, if you add like a transformer block, you're still taking away like the core benefits of Mamba, which is that it's just like it's linear, it's not quadratic. So if you add a transformer block, you're still making it quadratic in some parts of the model. And I have a thesis that if the architecture is constructed well enough, then you don't even need a transformer, because a Mamba can do just as good as a transformer. So I have a thesis that that could be the case. Um, and it says, "Damn, let me in." Ha ha ha. We're on Discord right now. We're in the Swarms Discord, so anyone can join in, and we could talk voice to voice. So, yeah, I just sent the link in the chat, so you could let me know if you see it. Yeah, now I need to find an MOE that I made previously somewhere. Oh, I think yeah, I could just use this. So I'm gonna take that. Wait, is this exported? I could just. Is this a pip? Is this a pip package? Um, I could just maybe try and input this. Seen Jamba? Yeah, Jamba is pretty interesting, but I think the model architecture could be, I guess so. I think it could still be improved. I don't think Jamba is the like definitive end, but they were like the first people that kind of like productionized Mamba model and made it usable. So congratulations to them. I actually met their team at a hackathon once, and I have their team gave me this free book bag. What is it? AI 21 Labs. So they gave me this cool book bag, and I still have it, and I use it every day. So, yeah. All right, now I'm gonna put a feed forward here. Open Kimi. I'm using a MOE that I previously made in one of my previous repos. So from Open Kimi. Okay, that works. That works. I'm just gonna take this and I'm gonna make a new class MOE. My computer is super laggy right now because I'm on both. I'm streaming and I'm on Discord, so this is not very good. But we're still gonna go. Where's this error? Is this the number of experts? Okay, we have the decoder. All right, let's see. Nope. This is not the main model. This could be. Okay.
Yo, guy, can you check manage? I made something.
Hold on, bro. Um, did you not hear me? I'm streaming.
Oh, no, no, I just got back. My bad.
Oh, yeah. This lag is killing me.
All right, bro. Kyle, I'm gonna leave now. I'll make the PR and I'll send you a message on Discord. Okay.
All right, sounds good.
All right, bro. See you, bro.
See ya. It's a Mamba. Fig. Decom. Self MOE dem equals MOE config dot dem. No. And experts equals MOE config and experts and activated MOE config and activated experts enter them. We're just gonna do that. Okay, now something very interesting that the Mamba team does is that they well, not the Mamba team, what am I talking about, the DeepSeek team, is that they use all RMS normalizations. So um they don't really use layer norm. I don't really know why, but yeah, they only use RMS norm, so I'm just gonna use RMS norm and then um, basically just implement like the layout of a transformer. So we're gonna take the residual here, then we're going to do oh, we need the norm. RMS norm. Dim equal Mamba. Config that dim. So no, let's see. So they do Mamba. No, this isn't what DeepSeek. This is what I was looking for. So okay. They do RMS norm, take the residual, do it, then add. Okay. All right. Norm. Say first equals self norm. Self norm. No. Okay. Mamba. Then same thing. We'll do second equals self Mamba. First. Wait, no. So okay, here they add the residual. Okay, so take the residual, normalize it, Mamba. Then oh, let me make the code. Can you see now? Should be easier to see now. Okay, RMS norm. This they take this. So the input to this second path is. Oh, this is the MOE. Okay, so take the add on norm, and then I'm trying to make this parallel, so this could be easier if I did this. I'm gonna just make this super simple. Take the residual. This is a slow version. Okay, I'm gonna do this the slow way. So first we norm it. Then we do Mamba out. We normed. Then we add the residual. Then MOE. So then we do normed again. So we norm the Mamba output. Then MOE. Say MOE out. normed again, and then you just add that. You add this to the Mamba out. Now this is, but I think this is like the simplest way to do this, but this is not very fast. Like this is not parallel at all. Say, make this inline. Um, I don't know if this would work. Yeah, that's not gonna work. This is the easy way of doing this. Now I actually need to test this, so I'm gonna have to implement this from scratch. Try. Okay, I need to leave Discord because I can't. It's too slow. I I can't actually do anything. Okay, so if that doesn't work, then we're gonna use from Mamba Pi import Mamba. Because hybrid models minimize the ratio of attention layers 1 to 8 or 1 to 12 to maintain high efficiency, so not always quadratic. But Jamba underperforms on few shot when TSFMR would. Hard to see the code, yeah, but I think Echo Mamba might really interest you. I think I read about Echo Mamba once upon a time. No, this is not Echo Mamba. Is this it? Is this the paper? Where's the paper itself? Is this on archive? Is it this one? I think I saw this once. Yeah, this is how like the basic Mamba looks like. Basic Mamba is like there's no FFN, there's no MOP. So I'm basically just trying to implement FFN into like a normal transformer decoder block, but no tension, and just replacing attention with Mamba. But yeah, I think there's a couple papers named Echo Mamba. So if you could let me know which one it is, that would be nice. Okay. Yeah, Jamba is also in this repo. This is just like a basic PyTorch only implementation of Mamba that doesn't do anything on the CUDA side. So I think I made an implementation for I think I made an implementation for Jamba at some point. Oh shit. This is getting complicated. Um I really don't like using data classes. I really do not. I do not like data classes. All right, I'm just gonna remove this for now. It's too complicated. I was trying to use the main Mamba repo, but I'm afraid it's too complicated for now. And I don't even have a GPU on this. Okay, so let's see. Okay. Also, I don't know if Kimi Linear. Another model that's like Jamba is Kimi Linear. They use Mamba. I don't know if they do use multi-latent attention. No. Oh, this is another thing I want to try. Kimi Linear is a paper that came out quite recently that uses this new attention called Kimi Delta attention. And this is basically how it looks like. So they have n number of these KDA blocks, and I want to see if we could like also replace this architecture with just Mamba. So maybe you have n number of blocks that use Mamba, and then you could have one block that uses multi-lane attention, which is the attention that DeepSeek uses. So I'm probably gonna try that now. And yeah. Mamba. Let's see. My computer is so like tweaking out. It's so slow. Vocab size equal 50,000. Say max sequence length is yada yada yada. Say depth. Dim. Super. Initialize all this stuff. Oh my god. There's like this massive delay right now on my computer. It's like really bad. It's slowing me down my typing. Um, I need to delete some tabs. Okay. So they have the embedding, then layers. Say norm. And I need to see the where is this? This is the DeepSeek repo. So they're taking this head. The head is self head is dim vocab size. Okay. I'm gonna do a post embed norm just for funds, because that can potentially help. Post embed norm equals post embed. Okay. For layer and layers. Return. Where is this image? They do. I'm just gonna make this sequential. Um. And that should be it for now. I mean, Mamba. I have so many ideas for Mamba, man. I have so many ideas. I have like an infinite number of ideas for Mamba. It's insane. Um, god. This computer's so slow. Let's see if this works. Ah, I do not like using D model. It doesn't. I don't like it. It should just be dim. Uh, and layers is equal to 1. Oh, yep. I'm just gonna do this for now. Yay, we got it to work. It's working. How nice. Finally. Okay. Kimmy Linear says, we also observed that Mamba 16, a typical linear intention that uses only multiplicative decay and lacks a delta rule, fails on all tasks in our model setting. What does that mean? Like, we would have to. We also observe. Where is this? 16. Synthetic test. Mama 2. I think Mamba needs like some sort of special it needs some sort of special like I don't know, rotary embeddings or like it needs something special like that to help it with this like positional encoding because all these different attentions have this like positional encoding or rotary embeddings and I think that like rotary embeddings is one of the most like important reasons as to why some models are performing well. So it's like I think that's I think that like Mamba needs some sort of like um rotary embeddings type of thing, or like positional encoding or something like that, because like as you processes like these sequences, I don't think like the model is really extrapolating the positions of the tokens, especially in like the state space. So it might be harder for state space models to learn the patterns between certain tokens and certain phrases. um I could be entirely wrong, but like that's something that I think could definitely be an issue in like the performance of SSMs. But like there's already like a bunch of papers uh, on Maba. There's like dozens or hundreds of them at this point. Like, yeah, look at all these. So it's not like they're completely useless. I mean, they are like very useful. There have been in some cases where in Mamba models too, they were using a Mamba for like video generation, and it was doing really good. I think it was this paper actually, or it might be this one. Um, There are definitely like some even robotics. I think Mamba models could be really good for robotics, because if you need to like like if you need to generate action sequences for a robot, you need to do it like very quickly. Transformers take too long to generate the action sequences for robots to take action, and a lot of people are trying to use Transformers for like VLAs, but I think Mambas could be a better alternative. And I actually worked on a model for that. I think it was called VLAM. Yeah, I think it is it this one? Yeah, it's this one. Damn, that was 3 months ago already. That's a pretty long time. But yeah, basically how this works is it's a VLA. It's a vision language action Mamba model, basically, and like it essentially generate like it takes in input images and it uses a vision encoder, and then like it outputs the actions in different like categories. So it's for like humanoids or dog, like the quadrupeds, and like other robotics like that. Also arms. You could do a humanoid, and I think this is a really good like research direction. I don't think anyone has ever used a Mama model for robots, and I think it could be useful because it's fast. Like you could generate like the SSMs generate sequences faster than transformers, so that could potentially be uh, very useful. We'll have to train a small little robot arm model and see how it does, but I think this could be a really good direction. It could also just be that the Kimi and linear people didn't necessarily like. I don't know. Maybe they made a mistake with the Mamba model or like how they use it. I don't know. I would have to see the exact code they used. Um, is this the Robot Mamba one? No, this is just something I built myself. Um, it's called VLAM. I gotta start writing more papers. If I wrote papers like, oh my god, if I wrote papers on all the Mamba models I've designed, I would probably be classified as like a Mamba prophet or something. Because I've worked on so many Mamba models, it's not even like comprehensible, honestly. 19 Mamba models. 19. Wow, that's a lot of Mambas. This Vision Mamba was the first ever. It was the first ever. Wait, no, is this the one? Vision Mamba. No. It's multi-model Mamba. I built the first ever Mamba model that processed images, audio, and video all at the same time. This one like blew up on Twitter. I was like, it was 2 years ago. Wow, that's crazy. Um, yeah, this one blew up on Twitter. It had like 500,000 views on my tweet or something, and like everyone thought it was super cool. Check LB Mamba. All right, let me see. Can you send me the full paper name? Because I can't find it. No, not that one. Yeah, I can't find it. Okay. You know what we could do? We could also try to incorporate MLA into this. So I implemented MLA earlier, um, but this this uses Triton. I'm not gonna be able to run this on my computer. Uh, let's see if we can. I hate using cursor, but I'm gonna do this for the sake of time. Okay. Check to see if the user has a GPU. If the user does not, then we need to implement a PyTorch implementations of the Triton kernels that we currently have. This MLA file, which I copied from the DeepSeek repo, uses Triton, and that's hard to use because I don't have a GPU on my MacBook, so that's gonna be a little bit difficult. It's gonna be a little bit difficult. No, I don't like I don't use cursor very frequently. And I don't like it when I have to use cursor. But like now I'm using cursor because this is kind of complicated and this would probably take me an hour to do to copy these Triton kernels into PyTorch. But I typically don't like using cursor. I don't like using anything honestly, like no like vibe coding tools. I like coding normally. Um in very few instances, like if there's just something I want to build super quick, I'll probably use cursor, but in most cases I really don't use anything. Um I just I don't know. I like coding. Free sys. No. I just need to rapidly test this stuff. this is too complicated. And pure PyTorch. I'm going to add a thing here saying post Mamba Emily Black. Yeah, this is too much. Yeah, this is why I don't like using cursor. I'm just doing this for the sake of time. Come on. Okay. Let's make an Emily block. Thoughts on diffusion language models? I'm very bullish on them. Uh, I've created a couple, and I've been advocating for them for a long time, and now I think a lot of people are starting to learn about them. I told David Holes, the founder of Midjourney, that like we were having this discussion about diffusion language models, and he was particularly interested in them, and I think now they've started working on them like full time. So like there have been some cool diffusion language model demos, but I think now like a problem is scale. Like you need to scale these up, and there's this one company that was doing them really well. I forgot their name, but I'm pretty bullish on them. You know, uh, I think they I think they could do really well. I just think we need to scale them up a lot, like maybe to like 50 billion parameters or something. What the hell did this thing have again? Let's see. This autocomplete stuff gets really annoying sometimes. Like really, really annoying. Um, okay, what was it? So first we norm. Um, I'm just gonna do this. Make it parallel because why not? Then we're gonna add the residual. Then we're gonna do this. Self MOE, self norm, first plus first. Then we're going to return. And that's a parallel block. Let me just organize this code. All right, let's see if this works. Oh, forgot to put my super in it. It works. It works. this is coming together quite nicely. Okay, so now we're going to initialize the MLA block, which is just one block. This is the config. Let's see, and experts. Just do that, and I could add heads. Heads. Okay. And heads. I don't like and anything. It should just be heads or dim. People are overcomplicating stuff. Okay. Now, this is the magic. If post Mamba MLA block is true, then we're going to hit it with the Mamba block or the MLA block. This is MLA test. Okay. Wow. It works. So basically what's going on here, I'll whip out my Excali draw. All right. Where's our little pen? Okay. So let's say we have input. This goes to n number of Mamba blocks. All right. So it could be like 10 or 10 to 20. Then we're going to hit it with one final multi-latent attention block. So say multi-latent attention block. Just one. And then this will go to the output head. And that's basically what I just built. And this is how Kimi Linear works, except Kimi Linear is doing this with KDA, which is Kimi Delta Attention, or whatever that means. So I basically just implemented this. You see, they have n number of these KDA blocks, and then you finally have this 1x final MLA block. And so I basically just built that with Mamba instead. Now, at some point, we will need to train this and see how it does. We will need to train this. I think this could work. I think it could work. Use and GDN and Mamba. The per channel decay is parameterized via low rank projection. WA down, WA bottom with rank equal to head dimension, and a decay function similar to those used in gated delta GDN. What is GDN? In Mamba. Before the output projection through WO is part of real numbers, dimension times dimension, use headwise RMS norm, and a data dependent gating mechanism parameterized as OT weights W sigma G. I wonder how this is read. How is this? What is this read as? WA positive, WA negative? What does this? How do you read this in math? All right, this thing is tripping. Dot product RMS norm KDA query key value alpha beta. Where's alpha? This might be alpha beta. We therefore hybridize KDA with a small number of full global attention, full MLA layers. For Kimi-linear, we choose a layer-wise approach, alternating entire layers over a head-wise one, mixing heads within layers. Right, it's superior infrastructure simplicity and training stability. Empirically, a uniform 3-to-1 ratio, repeating 3 KDA layers to 1 full MLA layer provided the best quality throughput trade-off. No position encoding, nope, for MLA layers. In Kimi layers, we apply nope to all full tension MLA layers. This design delegates the entire responsibility for encoding positional information and recency bias to the KDA layers. KDA thus is established as the primary positional wise operator, fulfilling a role analogous to or arguably stronger than auxiliary components like short convolutions or what is this? SWA. Our findings align with prior results, who similarly demonstrated that complementing global node potential with a dedicated position aware mechanism yields competitive long context performance. It's getting cold. It's getting very cold here. Convolution layer, lightweight device convolutions with a small kernel size can be effective at capturing local token dependencies and are widely adopted by recent architectures. Nope versus rope. There's been a lot of models that don't use positional codings. Pali used to be one. I think Gemini probably doesn't even use position codings. On a series of MOE models following the Moonlight architecture and all experiments, we activated 8 out of 64 experiments and utilized the Muon optimizer. For MLA, following the chinchilla scaling law methodology, we trained 5 language models of different sizes, carefully tuning their hyperparameters through grid search. Grid search. What does that mean? Grid search. They optimized the parameters using grid search. For KDA, we maintain the best hybrid ratio of 3 to 1. Following this we adhere strictly to the MLA training configuration without any modifications. Qlinear achieves 1.16x computational efficiency compared to the MLA baselines with compute optimal training. Oh, gated delta net. That's what GDN meant. This is a really good paper, by the way. I really like this paper. Mamba, there's the Mamba paper, the Mamba model, chunk the yellow PR. Pure linear attention still struggle with precise memory retrieval and exact copying. This deficiency hinders their adoption in industrial scale LLMs where robust long context recall and reliable tool use over extensive code repositories are critical. Recent work showed that linear attention and full attention can effectively complement each other, leading to various hybrid designs. One category of hybrid architectures is the intra-layer hybrid, which adaptively fuses the outputs of different mechanisms within each layer. A common implementation fuses outputs from heterogeneous heads from each layer, such as combining standard attention with SSMs. Would you look at that? That's exactly what we're doing right now. In contrast, sequence level approaches apply distinct mechanisms to different parts of the input. For example, some use linear attention for past context and SWA for recent tokens, while native, what was this? NHA, I forgot what attention variant that is. NHA compresses in the history with GSA and combines it with local sliding window context to emulate a standard attention operation. A key drawback of the intra-layer hybrid is the increased system complexity and inference overhead. The heterogeneous mechanisms require separate computational paths, complicating optimizations like distributed parallelism. To mitigate this challenge, inter-layer hybrids have become more widely adopted and practical strategy in LLMs. For the linear component of our hybrid, we deviate from the common practice of using Mamba 2. By interleaving KDA with global attention, can reduce memory usage by up to 75% while achieving 6.3x higher decoding throughput and outperforming full attention baselines. I wonder what these people have been up to. These AI 21 people. What have they been doing? I haven't seen anything from them. in addition to Mamba layer IMS, just 3, 6, 8. These are 8 blocks. 3, 6, 8. 8 blocks in total. I made an implementation of Jamba somewhere on my GitHub, all in pure PyTorch. Because there was no GitHub for this that I could find easily. So, but it was a long time ago. This was like whenever this paper came out, which is now approaching a long time. What are these people doing? Yeah, these people aren't doing anything. Jamba reasoning. Okay, this might be interesting. Well, what I mean, is there a paper or like what's going on with this? 26 Mamba layers, 2 attention layers. That's pretty crazy. So they're using GRPO on Mamba. That's pretty interesting. But I want to paper it. Like, I want to know what happens when you try to make a Mamba model of reasoning, or you try to like do some RL stuff like GRPO. I wonder if there's any distinction between GRPOifying a Mamba model. That would be particularly interesting. Mention rural volcano engine reinforcement learning. What is this? What is this? Um, let me see if I have any other ideas. I'm starting to get a little bit hungry. I have not eaten anything today. It's 4 o'clock right now. What can we do to this? This delay is making me very angry. Hmm. I have so many ideas. How do I do this? Linear time demonstrates superior performance. Memory efficiency, particularly for long context size. The Mamba series notably introduced selective state-space models to enable linear time sequence modeling with strong performance. In addition, hybrid architectures that combine a few attention layers with subquadratic layers. Mamba have emerged showing advantages over pure transformer and pure subquadratic designs. Such architectures are particularly suited to meet the high compute demands of inference grading and our work that investigates their scaling properties. I wonder varying the ratio of transformer allows balancing efficient training. MOEs of training flops. The basic component is a Jamba block. I'm surprised this model even works at all. Honestly, like the Jamba model is a mess. Some layers use MOP, some layers use MOE. There's attention, Mamba. I mean, it's a mess. It's literally magic as to how this model works. We used an in house proprietary framework allowing efficient large scale training, including FSDP, tensor parallelism, sequence parallelism, and expert parallelism. Jamba is trained on an in house dataset. Our data processing pipeline includes quality filters and deduplication. Uh, their in-house proprietary framework is literally FSDP. This is their in-house proprietary training framework. That's fucking hilarious. Let's see. Look at that retrieval, man. That is crazy right there. This little thing, this little chart, this is crazy. And I'll show you why. Say long agents. Look at this. I know this was a long time ago, but look at that. GPT-4 couldn't even process like GPT-4 has instances in which it cannot process the entire context window. It can only process a certain amount of the context window completely. This is Claude. So this is needle in a haystack. It's basically an analysis of the retrieval accuracy over token length. So needle in a haystack. And these are a bunch of models. Jamba outperforms all of them, which is very interesting. So these are the tokens from 1 to 128,000. And this is the like percentage, and green is like it retrieves it well enough, like good, and red is like it does not retrieve it. But you can see like the difference. That's crazy. That is insane. Collab for Sonnet technical report. It's 120 pages of Claude Sonnet technical report. I want to see if they have a needle in a haystack chart. Needle in a haystack chart. Let's see. My long-standing complaint of the needle is the needle is too obvious. Yes, by finding a needle within a haystack, a random collection of documents, which are languages, startups, and finding the work you love. I suspect this pizza topping fact may have been inserted as a joke or to test if I was paying attention. That's funny. Sentence does not fit within the other topics at all. The documents do not contain any other information about pizza topping. Opus not only found the needle, it recognized that the inserted needle was so out of place in the haystack that it had to be an artificial test constructed by us to test its attention abilities. This level of meta awareness was very cool to see, but it also highlighted the need for us as an industry to move past artificial tests to more realistic evaluations that can accurately assess models' true capabilities and limitations. This is funny. Um, Claude 3 did pretty good. Jama's is almost good as 3 Opus. I wonder how 4 Opus performs. 4 Opus. I really want to know the architecture of Sonnet and Opus. I really do. I really, really do. If I ever find out what this model is made out of, I'll be very happy. So I do not think that they're using a hybrid model at all. I do not think they're using hybrid. I probably think they're using they're definitely using some heavily modified attention variant and maybe MOE, but I don't like MOE. I don't think I don't know. I don't like it. All this MOE stuff that we're seeing now is because people thought that GPT-4 was using MOE, and I don't know if that was ever the case. I think that was just pure speculation. But now everybody's using MOE, MOE here, MOE here, MOE here there. Like I don't know. I don't know if it's I don't know. It doesn't feel right. MOE does not feel right. I don't like it. Redesign transformer stack, but the redesign is discussed only conceptually, not as a concrete diagram. It supports a very large context window on the order of 200,000 tokens. Interesting changes. Specialized long attention schemes, but the mechanisms are not documented publicly. This is treated as related to sustained state. Okay. On topic notes that Sun 4 builds on constitutional AI and is trained with extensive principle-based feedback and self-critique loops, again described as a conceptual level rather than a precise pipeline. Which Opus 4.5 definitely sparse MOE on GPT-5. That could be the case. Um, that definitely could be the case. To see the future, we must understand the past. To see the future, we must understand the past. Claude 2. Introducing Claude. I remember when this first came out. I really don't like the name Claude. They could have chosen something cool like Quinterion or like, I don't know, something futuristic. They chose the Claude. I don't like the name Claude. It's a good model. I like the model, but I do not like the name. The name doesn't sound cool. Hate the name too. Scamthropic. Hate the name too. Yeah, the name is really dumb, man. Um, I don't know. Like it's just I don't like it. It doesn't sound cool. It doesn't sound futuristic. All right, dude. This is AI. It needs to sound futuristic. It needs to sound cool. It shouldn't sound boring like Claude. Claude's boring. GPT sounds cool like ChatGPT, even though it's corny. For me, it sounds corny, but at least like it's catchy. It's like Claude sounds too much like a human being, and that should not be the case. There should be a clear distinction between okay, this is an AI and this is a human. But Claude is literally a human name. I think they did that so it could sound familiar because Claude is a name that people literally have. And thus they had the name so that it would sound similar to humans they might have met before as kind of like a psychological trick. But I don't think that's going to work in the long term. This was another joint hybrid Mamba model. It was Zamba. Zamba. Input 6 Mambas concat, attention MOP, normal block, linear Mamba, 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 attention MOP, linear Mamba, Mamba, Mamba. I don't think this one was ever open sourced. Oh, okay. It was open sourced. I also implemented this one, I think. I implemented this one. So they trained a model on AMD. Jesus Christ. This new Zaya. Zaya. Zaya 1. Zaya 1. Let's see what convolution this is. Compressed convolutional attention. Jesus Christ. What are these people doing? Embedding, CCA, self attention, RMS norm, router, MOP, yada yada yada. Door. What the hell is a door? Okay, this is pretty interesting. I don't know what this is. This looks like slop. This looks like slop, man. what? What is this? Zyphra. Let's. Oh, they don't have anything. So they have Zaya ZR1. Okay. ZR1. Prime, an online RL algorithm with process rewards motivated by the improvements of over GRPO demonstrated in the paper, as well as potentially more accurate token level rewards due to learn reward model. No think token prime start with 1 PPO epoch increased to 4 during 24 stage. More slop. More slop. Slop, slop, slop. Slop, slop, slop. What is this? This is not. Is there a paper for this? I'm just genuinely curious now. There it is. Is that Prime ML? What do you mean? Prime ML. This is Zyphra. Zyphra. These people love Z's. X. Zyphra. Multi-head attention to quadratic compute and linearly growing KV cache makes long context transformers expensive to train. Prior work such as group query attention, multi-lane attention, shrink the cache, decoding, speeding, decode, belief compute, which determines prefill and training speed. Largely unchained, we introduce CCA, compressed convolutional attention, and novel attention method, which down projects query keys values and performs the entire attention operation inside the shared lane space. Okay. The simple design dramatically cuts parameters, KV cache, and flops all at once by the desired compression factor. Because CCA is orthogonal to head sharing, we combine the two to form compressed convolutional group query attention. Jesus Christ. Which further tightens the compute bandwidth Pareto frontier so that users can tune compression towards either flop or memory limits without sacrificing quality. Experiments show that CCGQA consistently outperforms both group create attention and multi-lane attention at equal KV cache compression on dense and MOE models. Additionally, we show that whatever that is outperforms all other attention methods on MOE models with half the KV cache of GQA and MLA. Achieving an 8x KV cache compression with no drop in performance compared to standard multi-head attention. It drops the flop cost of attention, which leads to substantially faster training and prefill than existing methods. On H100s, our fused kernels reduce prefill latency by 1.7x at a sequence length of 16K relative to MHA. This, I mean, I don't even know. This sounds like slop. Slop. I want a Mamba model that shows you how to train it with GRPO. Or like, you know what I mean? Like GRPOifying a reasoning model, Mamba reasoning. There has to be some paper called Mamba R1. Oh, would you look at that? The Swarm Corporation. Yeah, that was my attempt to do so, but I want to see if someone actually has done this. M1. So mixed language open source model. Hunwan. Hunyan. Hunyan. This could be a pretty large Mamba model. Is there a paper? Honyan base. So the what is this model? Does this use Mamba? If it doesn't, I don't care about it. Honyan. So it's not open source. Or is it open source? Because I don't see shit. If I was going to trade a model right now, I would probably follow everything in the Kimi K2 paper. Kimi K2's paper is really good. I made a list of the I made a list of the most important research papers to read right now, and honestly, the Kimi K2 paper would probably be like at the top of the list. Like everything about this paper is just perfect. I don't know. Like if I wanted to build a frontier model right now and I had less than $100 million, I would read this front to back. They use Muon, which is faster than Atom. 1.04 trillion parameter MOE model with 32 billion activated parameters. This is such a good paper. Do they use distillation? I'm pretty sure they do. They definitely do for the RL side. For the RL side, the RL section they have is pretty extensive. To support this, we develop that facilitates RL across a wide range of scenarios. We extend the framework with a large number of tasks with verifiable rewards for tasks that rely on subjective preferences, creative writing, or open content. We introduce a self-critic reward in which the model performs pairwise comparisons to judge its own outputs. This approach allows tasks from various domains to all benefit from the RL paradigm. Um, I think they use distillation. I'm not 100% sure, but they're training the model on its own outputs. So beyond verification. To extend model alignment beyond tasks with a verifiable reward, we introduce a framework for general reinforcement learning from self-critic feedbacks. It's like self-distillation. This approach is designed to align LLMs with nuanced human preferences, including helpfulness, creativity, depth of reasoning, and factuality and safety. The framework operates using a self-critique rubric reward mechanism where the model evaluates its own outputs to generate preference signals. To bootstrap K2 as a competent judge, we curate a mixture of open source and in-house preference datasets and initialize its critique capability in the SFT stage. Self-critique policy optimization. In the first core of the process of the learning, the K2 actor generates responses for general prompts that covers a wide range of use cases. The K2 critic then ranks all results by performing pairwise evaluations against a combination of rubrics, which incorporates both core rubrics, which represent the fundamental values of our AI assistants that Kimi cherish. That aim to eliminate reward hacking, human annotated rubrics crafted by our data team for specific instructional contexts. K2 retains the flexibility to weigh them against its internal biases. Capacity enables the dynamic and continuous alignment with its evolving on-policy behavior, ensuring that the model's responses remain coherent with its core identity while adapting to specific instructions. We adopt a policy optimization algorithm introduced as a foundation for K2. For each problem, we sample K responses from the previous policy pi old and optimize the model R pi theta with respect to the following objective LRL. As an SF2, we employ the Muon optimizer to minimize the objective as we scale RL training to encompass a broader range of tasks and can make it to a primary challenge. A primary challenge is achieving consistent performance improvements across all domains. Yeah, this paper is very, very specific. It's very, very specific on the RL setup that they used, which I think is very interesting. There's not that many other papers that have this detail elaborateness. The most important thing about this paper that I've seen is that it could do upwards of like 200. It could do like 200 think action like 200 steps of like think action, which I've never seen anyone do. Like you see like thinks action, think action, think action. It does this really well. Where is this? They made their own large scale agentic data synthesis. Agents interact with simulated environments and user agents, creating realistic multi turn tool use scenarios. An LLM judge evaluates simulation results against task rubrics, filtering for high quality training data. Um, I don't know what MOM distillation is. Preference data sets. Yeah, it sounds like they're using something like that. Did you see the million steps zero mistakes paper? Uh, I did. Um, what is it? Zero mistakes. All right, I forgot million. I don't know how it's. I briefly read it, but I don't know how it works. If this was true, like a million steps, no mistakes, like the world would, I think, immediately change. I think we would know if this was like functional. I don't know. There's like mm, tiny steps. If a model can only generate 8,000 tokens at maximum in one generation, like I don't think it. I don't think it would be. Let me just read this. LLMs have achieved. The models have persistent error rates that prevent scale up. Thus, although LLM research is often still benchmarked, there is an increasing tension on the ability or inability of LLMs to perform large reach tasks. This paper describes Maker, the first system that successfully solves a task with over 1 million LLM steps with zero errors and in principle scales far beyond this level. This approach relies on extreme decomposition of a task into subtasks, each of which can be tackled by focused micro agents. The high level modularity resulting from the decomposition allows error correction to be applied at each step. Through an efficient multi-agent voting scheme, this combination of extreme decomposition and error correction makes scaling possible. Thus, the results suggest that instead of relying on continual improvement of current LLMs, massively decompose agentic processes. So they use models to determine outputs and vote to best. Then the best moves forward. Komodo. What is Komodo? Oh, Komodo. $200 per run. I have to read this paper in full detail to truly understand this. Sequence of at which point in the universe spawn. Komodo is a really famous restaurant in Miami. Is this the model? Or what is it? The first element. If you could send me the name, the full name of the paper, that would be nice. I can maybe create a simple implementation of this, but I need to read this full paper, the whole thing. Um, all right, I think I need to eat something now. I have not eaten a single thing today, and it's 5 o'clock. It's 5 p.m. right now. That's crazy. All right, I think I'm gonna go eat something, and then I'll be back in the Discord. Agman, you should join our Discord. We can continue our conversation there. I really need to eat something. But yeah. Thank you for joining the stream, and yeah, I want to stream more often. I have so many things to talk about, so many things to build and show, and I don't know. I need to just stop being so shy and just stream more often. But yeah, thank you everyone for joining. Thank you, Agmans, and thank you to everyone else. And